Hi friends, in the previous lecture we have already studied about basics of operational amplifier. We studied that it can be used as a voltage amplifier, it can be used as a comparator, it can also be used as oscillator circuit. In this lecture we will study about operational amplifier when it is operated as voltage amplifier in detail. Let's say this is an op amp. We have studied that these are two inputs of operational amplifier, and here we have output. This input is called inverting input. Inverting input. And here we have this is called non-inverting input. This is output, and this is A is gain of this operational amplifier. A is oftenly called the open loop gain. Open loop gain, because normally when it is acting as voltage amplifier, it is connected to external circuit, and there is a feedback in this op amp. So if there is a feedback, we will have a closed loop gain, and if there is no feedback, if this is input, this is output, A will be the open loop gain. Let's say the voltage of this input is V minus and this is V plus. The output will be A into V plus minus V minus. You subtract these two voltage, V plus minus V minus, and multiply with the open loop gain, you will get the output. And what we studied in ideal case, what will happen? In ideal op amp, its input impedance, this will be infinite, and its open loop gain will also be infinite. Each amplifier has some input and output impedance. There will be some input impedance. We will represent it as Ri. And each amplifier also have some output impedance. So output impedance of an ideal op amp will be 0. Okay. So what we studied in previous lecture, in ideal case its gain is infinite. So from this formula it seems that if you have some potential difference here, if you connect a voltage here, here also a voltage, and if it has some finite voltage difference, okay, the gain is infinite, so it seems that output will always be infinite. I will write here it gain tends to infinity, not exactly infinity. So if this difference is finite, this quantity tends to infinite, and if this difference is finite into a quantity tending to infinite into a quantity which tends to finite, you will get infinite. So it seems that if this operational amplifier is operated as it is, it will give always an infinite voltage, but the supply voltage is not infinite, so in this case it will give saturated output. This will give saturated output. There will be some saturation voltage. Let's say this is Vsat and minus Vsat. So if this voltage is greater than the non-inverting voltage, this will give negative saturation voltage, and if this voltage is greater than inverting voltage, this will give positive saturated voltage. Okay, now if you want to get a finite output voltage, we will have to connect this op amp as a negative feedback. This is Ri and this is open loop gain voltage. The potential of this terminal will be V minus, and this is V plus, and output will be written as A into V plus minus V minus. Now when we will connect this op-amp to a system, let's say you have a voltage source, and along with some resistance if you connect here, now this will make a system. Let's say this is input voltage and it has resistance R input, or let's say this resistance is R1. Here we connect a resistance RF. The non-inverting input has been grounded, and to inverting output we have connected a voltage source with a resistance R1, and there is a feedback from output voltage with a resistance RF. So this type of feedback will be called negative feedback. This feedback will be called negative feedback. And we will shortly derive that if this op-amp is connected as a negative feedback, we will get a finite output voltage, despite of the fact that its open loop gain is infinite, but we will get a finite voltage. Okay. If you want to calculate the feedback factor, how much feedback is coming from the output voltage to this terminal, if you want to calculate feedback, obviously feedback will be of this output voltage. So what we will do, you want to calculate the voltage at this terminal due to output voltage only. Okay. So with the help of superposition, what we will do, we will short this voltage and we will calculate voltage at this point. Now whatever will be the voltage at this point, this voltage will be due to output voltage only. So let's say this voltage is V. Now if you will apply nodal analysis at this point, you will have this current plus this current equal to the input impedance of ideal op-amp is always infinite, so there cannot be any current in this direction. So this current plus this current will be 0. So this current is V divided by R1 plus current in the feedback resistance is V minus V0 divided by RF. V minus V0 divided by RF. This is equal to 0. So we will have V into 1 upon R1 plus 1 upon RF is equal to V0 by RF. So V will be V0 into R1 divided by R1 plus RF. So V divided by V0, this is nothing but, V is nothing but feedback voltage. V divided by V0 equal to R1 divided by R1 plus RF. So we'll say we have this much of feedback factor. And since this feedback is coming at inverting input, so this feedback will be called negative feedback. If we had a feedback of output voltage into the non-inverting input, that feedback would be called positive feedback. Okay, so this was about feedback. What we have to study, you have, I hope you understood a negative feedback. Okay, we have to study that if this ideal op-amp is connected as a negative feedback, its output will be finite, and we will derive formula for output as input into minus RF divided by R1. You would have studied this formula. There are two formulas. Okay, we will study it later. Okay, so before deriving this equation, we will study more basics or more terminologies. Okay, we have a input voltage. Okay, obviously this input voltage will be with respect to ground. Here we have input voltage, and this voltage will be with respect to ground. Okay, this is the input voltage, and obviously this output voltage will also be with respect to ground. This is output voltage. Okay, so when this op amp is connected as negative feedback in this system, there will be an input voltage to this op amp. For op amp, what we write? Gain into V plus minus V minus is equal to output voltage. What is for op amp? We write this formula. So what will be input for op amp? This is input, this is gain. So we will write VA into VI is equal to V naught. Okay, so there are two inputs in this system. The one input is which comes to op amp. Okay, we will represent it as VI, and there is another input which is main input to the system. So I will represent the main input as Vn and the input to op amp as Vi. Similarly, the input resistance of op amp will be Ri. This is input resistance or input impedance of op amp. There will be one more quantity, Rin. This will be input impedance of this system. Input impedance of this system, or simply input impedance of system. Okay, Ri will be input voltage to op amp divided by input current to op amp. Okay, and input impedance of system will be input voltage to the system divided by input current to the system. This voltage divided by this current will make input impedance. Okay, similarly, there will be one gain of operational amplifier. A is open loop gain. Okay, this is gain of operational amplifier, which is infinite in case of ideal op amp. There will be one more quantity, AV. We will represent it as AV. This will be gain of the system. It is not necessary, as we will derive, it is not necessary that the open loop gain of the system op amp or the gain of the system will be equal to the gain of the op amp. This is not necessary. Gain of system. Okay, in this case, if we talk about the output voltage of op amp and output voltage of system is same. If I draw a dotted line, this is our op amp. Okay, and this makes, along with op amp, feedback resistance, input resistance, this R1, this makes our system. Okay, so we can define gain, input impedance, output voltage, input voltage for op amp also and for system also. So what we have to do here, we have to find out the gain of the system. We already know the gain of open loop, gain of the op amp is infinite. We have to derive formula for gain of the system, and in this case some of you might be knowing that the gain of the system will be minus Rf divided by R1, that is the output voltage of the system divided by input voltage of the system. Let's say we have an operational amplifier which is connected as negative feedback in this system. We have to derive formula for gain of the system, which is system output voltage divided by system input voltage. And since this operational amplifier is infinite, so its gain will tend to infinity and input impedance will also tend to infinity. So in this operational amplifier, we have given input at inverting input. We have given a voltage with a resistance R1 at inverting input, and we also have a feedback at inverting input only. So this will be called negative feedback, and here feedback factor is, as we have calculated previously, the feedback factor is R1 divided by R1 plus RF, and we have connected non-inverting input to ground. So for output voltage, what is the op-amp input voltage? For op-amp, if we write the formula, we will write output is equal to A into V plus minus V minus. V plus is nothing but 0, and what about V minus? This is at V input. There will be some current here. We don't know the value of current, but there will be some voltage drop. So V input minus this voltage drop. So V input, this V minus will be, for now this is unknown. So we will assume it V minus only. So V naught will be minus A into V minus. Okay, so there will be some flow of current. Some amount of current will flow in feedback resistance. What about current in this resistance? Since the input impedance tends to infinity. Okay, if we talk about this resistance, current in this resistance, current will be, if we take this direction as a reference of current, the current will be V minus minus V plus divided by R input. Okay, since we have connected a finite voltage here, so V minus cannot be infinite. If your input voltage is finite, there will be some voltage drop, so V minus can never tend to infinity, and this current will be input current to the operational amplifier. Okay, this is V minus divided by Ri, since V plus is 0 and V minus is a finite quantity, divided by Ri tends to infinity. This is infinite. So finite divided by infinite, this will give you a quantity tending to 0. So we will say the input current is 0 here. Okay. Now if the input current is 0, can you say that if this current tends to 0, these two voltage has to be same? For now we cannot say that. Even if the Y input current is 0, this current is 0 not because this voltage is 0, because the resistance tends to infinity. This is also possible that, let's say you have connected a 10 volt here, 2 volt here, and resistance is very high. Let's say this is 2 giga ohm. So the current will be approximately 0. Now if the current is 0, can you say that two voltages will be same? No. Here we still have a potential difference of 8 volt, but current is 0 because resistance is very high. So in the similar way, if current is 0 here, we cannot say these two potential will be same. So for now we cannot say V minus is also 0. We will assume it as V minus only. Okay, so we have found out we have the value of output voltage in terms of V minus, but we have to get output voltage in terms of input voltage. So we will apply nodal analysis here. If we apply nodal analysis, we will have V minus minus V input divided by R1 plus, here we have 0 current, plus what will be this current? V minus minus V output divided by RF. This is equal to 0. So we will have V minus minus V input divided by R1 plus V minus, what is V output? V naught is equal to minus of A V minus divided by Rf equal to 0. So from here we will have V minus into 1 upon R1 plus 1 upon Rf plus A divided by Rf. This is equal to V input divided by R1. So V minus is equal to V input divided by R1 divided by 1 upon R1 plus 1 upon Rf plus A divided by Rf. Now if we analyze it, V input is finite, and I forgot to tell you that these are external resistances. These are finite resistance. Normally the values of these resistance are in kilo ohm. Okay, so this is finite, this is finite. In the numerator you will get a finite quantity. Here this is finite, but the open loop gain tends to infinity. So overall in denominator you will have an infinite quantity, and finite divided by infinite, this will tend to 0. So what you are getting here, V minus tends to 0. Okay, so now we can say that these two voltages are same. And if you see it carefully, what is the reason for this V minus to be 0? The reason of these two voltages are same, the reason for this is not that this resistance is infinite. If you see this expression, why this voltage is going 0? Because the open loop gain tends to infinity. Okay, so if this operational amplifier is non-ideal, it means if open loop gain does not tend to infinity, in that case V minus will not tend to 0, or we can say that V minus will not be equal to V plus. What we are having here, we are getting V minus as 0. If you take this potential not as 0, if we had taken this voltage as 1 volt, then here we would got V minus as 1 volt only. So in general, if these two conditions are satisfied in a negative feedback operational amplifier, these two conditions are satisfied, means operational amplifier is ideal. And if you have connected it as negative feedback, you will have V plus is equal to V minus. In this case V plus is 0. These two voltages will be same. So this is one of the important factor, or this is the one of the important thing we need to know in case of operational amplifier when it is connected as negative feedback. Now if we want to calculate the output voltage is A into V minus. Okay, what I have said, V minus is not absolutely 0, V minus is tending to 0. Now if you see this expression, A tends to infinite, this tends to infinity, and V minus tends to 0. So quantity tending to infinity into a quantity which tends to 0, you will get a finite quantity here. V naught is equal to A into, what is expression of V minus? This is the expression, A into V input divided by R1 divided by 1 upon R1 plus 1 upon Rf plus A divided by Rf. Okay, in the denominator you have an infinite quantity, in numerator also you have a quantity which tends to infinity. So you have infinite by infinite form. If you divide with A both in numerator and denominator, you will get V input divided by R1 divided by 1 upon AR1 plus 1 upon ARF plus 1 upon RF. Okay, this quantity is finite. What about this quantity? This will tend to 0, this will also tend to 0. So what we will get here? Here we had minus sign. Okay, V naught equal to minus A into V minus. So we'll also have a minus sign here. Okay, so V naught equal to minus V input divided by R1 divided by 1 upon RF. This will be minus V input into RF divided by R1, or V output divided by V input, which is nothing but gain of the system. This is minus RF divided by R1. So in this derivation, the most important thing is, if this op amp is connected as negative feedback, these two voltages will be same. In this derivation we have derived even this result. Even this result I have derived in this derivation. But in the question, as soon as you will see that it is connected as negative feedback, you don't need to derive it. You will immediately equate these two voltages, and when you will equate these two voltages, the derivation for system gain will be very easy. Okay, let me show you how this will become easy. This is V input, V output, R1, RF, and negative, positive, this is grounded. So this is connected as negative feedback, it is connected to 0, so potential at this point will be 0. So now if you apply KCL here, this current will be 0 minus V input divided by R1 plus, here current will be 0 due to infinite input impedance. And what is current here? 0 minus V naught divided by RF. So from here you will get V naught divided by V input equal to minus RF divided by R1. So what is the effect of negative feedback? Initially what we have seen, V naught equal to A into V plus minus V minus. Okay. What I said earlier, if this quantity is finite, A is infinite, you will always get infinite quantity. But what is the effect of feedback here? And then due to negative feedback, these two voltage becomes approximately equal. Okay, so you have an infinite quantity here, but these two quantity becomes approximately equal, so this quantity will tend to 0. Now the limit of infinity into 0, this will give you a finite quantity. Okay, so if you remove the negative feedback, you will always get a saturated output voltage. Infinite output voltage means saturated voltage. This will be V saturated. Or even if you connect a positive feedback, let me give you an example of positive feedback. Let's say you have connected an input voltage here. This is plus. Okay, so here feedback is coming at the non-inverting input of the op amp. So if output is coming, a part of output voltage is coming at the non-inverting input of the operational amplifier, this will be called positive feedback. And in this case, this quantity will not tend to 0. In this case, this quantity will even increase. Okay, so in this case also you will get saturated voltage. And if voltage saturates, the curve or the graph between output voltage and input voltage will not be linear. This circuit will not be linear. But here if you draw the graph between output voltage and input voltage, this will give you a constant. Okay, here you will get linear curve. So this can be operated as voltage amplifier. Okay, so if op amp is ideal and it is connected as negative feedback, then V plus will be equal to V minus. And after doing this, Now solving or calculating the gain of amplifier will involve only the analysis of a network system. There is nothing will be left as an analog circuit. The concept is this much only. Okay, what is necessary? It should be as negative feedback. It doesn't matter where you have given the input voltage. This input voltage may be at inverting amplifier, and it may also at the non-inverting amplifier. Let me give an example. The important thing is the feedback from output must go to the inverting amplifier. It does not matter where you have connected the input voltage. This is non-inverting amplifier, and let me connect input voltage here. Okay. This is non-inverting. So here input voltage is connected as at non-inverting input, but feedback is coming at inverting input of the amplifier. So this is also a negative feedback system. Negative feedback. So here also these two potential will be same. Okay. You can also derive formula for gain here. Since this is negative feedback, so this voltage and this voltage will be same. If we talk about current in this resistance, if any current that flows through this resistance will enter into the amplifier, and the input impedance of amplifier is this tends to infinity, so there cannot be any current here. If there is no current, there is no potential drop across this resistance. So if this is at input voltage, this potential will also be at input voltage. Now these two potentials are same due to negative feedback, so this point will be at input voltage. Now as I said, in this question only network analysis is left. If you are strong in solving question of network, electrical network, you can easily solve question of operational amplifier in negative feedback. So if you will apply nodal analysis here, V input divided by current will be V input divided by R1. Here current is 0. In this direction current will be V input minus V0 divided by RF equal to 0. So here you will get V output divided by V input, which is gain of this system. This will be 1 plus RF divided by R1. You can also derive this formula without this initial assumption that these two voltages are same. Without assuming this initial assumption, as I did in case of when the input was connected at inverting amplifier, you can initially assume, just for the derivation purpose, that these two voltages are not same. Since current is 0 here, this will be at input voltage, and you assume that this will be at V minus. So you will write expression for output voltage as A into V plus minus V minus. V naught will be A into V plus is V input minus V minus. This is one equation. And applying at nodal analysis at this terminal, you will get second equation, and in the second equation you will put V naught as this. The second equation will be V minus divided by R1 plus V minus minus V naught divided by RF equal to 0. This current is 0. Now in this equation you will put V naught equal to A into V input minus V minus. Okay. V naught equal to, V naught will be in terms of V minus, and when you will solve for V minus, you will get finite divided by infinite, this type of quantity. No, you will not get this type of quantity. if you will solve these two equations, okay, let me solve it. V minus divided by R1 plus V minus minus V naught is A into V input minus V minus divided by RF equal to 0. So V minus into 1 upon R1 plus 1 upon RF plus A divided by RF, this will be equal to A into V input divided by RF. This is not negative minus here, this is V minus, and here we have multiplication. So V minus will be A into V input divided by RF divided by 1 upon R1 plus 1 upon RF plus A divided by RF. Now we divide both in numerator and denominator by A. Okay. Now since A tends to infinity, this will go to 0, this will also go to 0. So you will get V minus as V input by RF divided by 1 by RF. You will get it as V minus equal to V input. Why you are getting V minus as V input? Because V plus is equal to V input. So in general, if you have V plus here, V minus will become V plus. And what is the reason? The reason is this quantity tends to infinity. Okay. If this quantity does not tend to infinity, okay, if A does not tend to infinity, this quantity and this quantity will be significant, okay, and this will get added to 1 upon RF. So you will never get V input. I will show you an example where A does not tend to infinity. Okay, in that case I will show you these two voltages are not same. Okay, so in this question we have V minus equal to, or absolutely what we will write, V minus is equal to V input divided by R1 RF divided by this. And what is V output? V output is A into V input minus V minus. So V minus V output will be A into V minus, what is the value of V minus? Let me write it here from here. A into V input by RF divided by 1 upon R1 plus 1 upon RF plus A divided by RF. These two will be cancelled. Okay, and now you divide denominator with this A. You will get V input by R1 plus V input by RF divided by 1 upon AR1 plus 1 upon ARF plus 1 upon RF. This will tend to 0, this will tend to 0, so V naught will be, you multiply this with RF, V input into RF by R1 plus V input. So V output divided by V input will be 1 plus RF divided by R1. Okay, so this way we have derived for both cases. The first case is when the input is applied at inverting input, and the second case when the voltage is applied at the non-inverting input. In both cases, if we have a negative feedback, these two voltages will be same, and if you will if you will do the calculation on this basis, calculation will be very easy and you can derive formula for gain of the system. Now I will take next example in which I will not take gain as infinity, and in that case I will show you that these two voltages will not be same, and this formula, or minus Rf by R1, this formula will not be valid. This is formula when input is voltage is applied at inverting input. Let's say we have an operational amplifier, and this is non-ideal operational amplifier, in which where is non-ideality? Non-ideality is that its gain is not infinity, its open loop gain is, let's say it is 5, and in terms of its internal impedance this is ideal, Ri is infinite. There is one non-ideality, and I am connecting it as negative feedback. This is output and this is grounded. Normally it is grounded through a resistance. I will tell you the reason why we connect. Although in the calculation this resistance does not make any difference, but there is a reason of connecting this resistance. I will tell you in other lecture when we will talk about offset voltages. Let's say this is 1 kilo ohm, this is 6 kilo ohm, this is input voltage. Okay, so now if we apply this concept that this potential and this potential is same, okay, that is applicable only when gain is infinity and input resistance is also infinity. But if we apply this concept, these two voltages are same, what gain we will expect? If these two voltages are same, this is at 0 volt, no current can flow here, so there is no potential drop, this will be at 0 volt, this is also at 0 volt. Now if you will calculate, this current plus this current will be 0. 0 minus V input divided by 1 will be equal to 0 minus plus 0 minus V0 divided by 6 equal to 0, and in this case you will get output divided by V input, which is voltage gain of the system, as minus 6, which is not correct. Okay, now we will, because this is applicable only when the open loop gain tends to infinity, so this is not the case, so we cannot apply the ready-made result V minus equal to V plus. Now we will go with the procedure. Okay, so to go with the procedure, I will connect an internal impedance here which tends to infinity, and this is at 0 voltage. I will take V plus as 0, and this is not 0, this will be an unknown for now. We have V minus, output voltage is A into V plus minus V minus, open loop gain is 5, okay, V plus is 0 minus V minus, so V0 will be minus 5 into V minus. Now we will apply KCL here. We will write V minus minus V input divided by 1K is plus V minus minus V0 divided by 6K equal to 0. Now what is V output? V output is minus 5 V minus, V minus minus V input plus V minus minus V output is minus 5 V minus divided by 6 equal to 0. So from here you will get 6V minus divided by 6V minus 2V minus equal to V input, or let me write it in other way. You will get it here as, I am trying to write in the same way as we wrote the expression of V in terms of voltage gain A. So you will have here V minus into, this is 1, here you will have 1 by 6, here you will have plus 5 by 6, where 5 is the gain. This is equal to V input. So V minus will be equal to V input divided by 1 plus 1 by 6 plus 5 by 6. Now if you will calculate it, you will get it as V input divided by 2. But if at the same place we have gain as 5 here, if this gain was infinite, or if this gain was tending to infinite, what would be the value of V minus? V minus would tend to 0. Since the gain is not infinite, okay, we are getting a finite value of V minus. So this voltage is 0 here, and this voltage is nothing. This voltage is V input by 2. And what is the reason of this inequality? The reason for this inequality is we have a non-ideality here. Now you have V minus equal to V input by 2. What will be the output voltage? Output voltage is 5 minus 5 into V minus. Minus 5, what is V minus? V input by 2. So here gain will be minus 2.5. And what gain you were expecting? You were expecting minus 6. Okay. So while equating these two voltages, you have to take care that op-amp should be ideal, means this should be infinity, and it must be connected as negative feedback.